So in number 1, this is asking me if the relation below is a function. First thing I need to check is I need to make sure my x values don't repeat, and none of them do. That's all I need to do actually. None of them repeat, so this is a function. If I had an x value that repeated, I would say no. Number 2 wants me to find the inverse given f of x equals 2x plus 7 divided by 4. So to do this, I switch my x and y, the spots they're in. So I'm going to have x equals 2y plus 7 divided by 4. Then I want to go ahead and solve for y. So I'm going to multiply both sides by 4. This gets me 4x equals 2y plus 7. Then I want to go ahead and subtract 7 on both sides. I get 4x minus 7 equals 2y. Then I can go ahead and divide both sides by 2. And I get y equals 4x minus 7 divided by 2. For my inverse, I just want to go ahead and write it back with inverse notation. Oops, I wanted the whole thing boxed. But that's the answer here. Number 3 wants me to graph this function and state the transformations from the parent function. So first thing I do is I want to find my vertex. It's opposite the sign of the x, same sign as the number on the outside. So it's going to be positive 2, negative 4. I'm going to go plot that point, positive 2, negative 4. And then this is a cubic function, so cubics look kind of like this. If it had been squared, that would have been U-shaped. It's got a 1/2 out front, so that means it is going to be wider than normal. So kind of like this. So it wants me to state what the transformations are. It goes, the normal one would be starting here and look more like this. It'd be skinnier. This is the parent. And this is f of x. So my transformations are right 2, down 4, and then vertical shrink of 1/2. Fractions are shrinks, whole numbers are stretches. Number 4 wants me to decide if this function is 1 to 1. What I do here is I want to first see if it passes the vertical line test. Oh, I know it passes the vertical line test. It tells me it's a function. I want to see if it passes the horizontal line test. So over here, it is touching twice. So I'm going to say no, fails the horizontal line test. Number 5 gives me this graph and it wants me to find the following. It wants me to find the domain and range. Because this is like a calculator screen and it's cutting off, I assume it's going left and right forever. Remember, domain is my x's, range is my y's. So it goes left and right forever. That's going to be negative infinity to positive infinity. Whenever I write infinities, they always get parentheses. My range is the y values it's between. So it's between here, and it bounces back and forth. It can be -1, so it gets a square bracket, and it can also be +1. So that also gets a square bracket. This tells me it's in between those two ranges, and the square brackets mean it can include those numbers. The only time I would not include them is if I had something like an open circle right here. That would mean to not include it. Okay. Number 6 says, given the graph, find the open intervals where it's increasing, decreasing, and constant. Open intervals means use parentheses. So then what I want to do is increasing is where it has a positive slope. So it's got a positive slope right there. It starts on the left side and stops at the value of -6. So negative infinity to -6. And then it starts up again at an x value of -1 and stops at the x value of 0. Then I want to find my decreasing. That's where it has a negative slope. So right there, that starts at -6. and stops at the x value of -4. Whenever I'm doing intervals, it's always just my x values. And then constants are where it has flat lines. So it's got a flat line here between -4 and my x value of -1. And then it starts up again at 0 and goes to the right forever, so to infinity. Number 7 gives me these functions and wants me to find the following. The first one is adding the two functions together. So I'm going to take 2x minus 5 and add 5x plus 3. Then I just combine like terms. 2 plus 5 is, let me rewrite this so I remember what I'm doing. 2 plus 5 is 7x. And then I have -5 plus 3, which gives me -2. B is h minus g. It gives me 3 functions, so I want to pay attention to that I'm picking the correct one. H is the very last one. So I'm going to do 2x squared minus 6 minus my g function, which is f of x plus 3. Then I want to go ahead and distribute that negative. This is something that was commonly missed on the test. So the first part stays the same. This negative is going to go to both the 5 and the 3x. So then it's going to be minus 5x minus 3. And then I just want to go ahead and combine like terms. So I have just a 2x squared, nothing to combine it with, just a -5x, a -6, and a -3, which gives me -9. Okay. Number C, because these two letters are written next to each other with nothing in between, it's assumed they're multiplying. So I'm going to multiply these two functions together. These are my first two functions. I can either FOIL or distribute. Both methods will give me the same answer. I want to take my first two terms. 2x times 5x gives me 10x squared. 2x times 3 gives me 6x. -5 times 5x gives me -25x. -5 times 3 gives me -15. Then I just want to go ahead and combine like terms. So then I have 10x squared plus, these two get combined together. 6 minus 25 is, oops, this actually should have been negative. This gets me -19x, and then minus 15. So this is my final answer here. D wants me to divide the two functions. G of x was my second function. F of x was my first function. So I'm going to do 5x plus 3 divided by 2x minus 5. Another commonly missed thing on the test was not giving my domain restriction. When I set it up like this, I've gone from being able to plug anything into my f function to restricting my domain. So now I need to take my denominator and set it not equal to 0. I want to add 5 to both sides. I get 2x equals 5. Divide both sides by 5. This gets me 2, oops, I divided by the wrong number too. I should have divided by 2 because that's the number in front of my x. And this gets me 5 halves. So then I have to write as part of my answer, x can't equal 5 halves. This whole thing is my answer here. On E, it has h of f of x. This means plug in f for x in h. So, every time I see an x in my h function, I'm going to plug in the function for f, which is what I've done right here. Then I want to go ahead and multiply that out. So, remember, squareds really mean I have 2 of the same thing in parentheses. I'm going to leave that 2 out front for now. 2x times 2x is 4x squared. 2x times -5 is -10x. Negative 5 times 2x is negative 10x. Negative 5 times negative 5 is positive 25, and I still have the minus 6 at the end. Then I want to go ahead and distribute the, actually I'm going to combine like terms. So I have 4x squared. Negative 10 minus 10 is negative 20x. Plus 25, plus that 6 at the, minus that 6 at the end. Then I can distribute that too. That's going to give me 8x squared minus 40x plus 50. And then minus that 6 at the end. Then I can combine like terms. Which gets me 8x squared minus 40x plus 44. And that is my final answer here. Okay. Next one wants me to solve the equation. What I want to do here is I want to look for my lowest common denominator. So what number multiplies for all of these? 3 and 6 both multiply into 6, and then I want to get rid of that x on the bottom, so I'm going to multiply the entire equation by 6x. So I'm going to have 6x times 1 over x plus 6x times 1 over 3 equals 6x times 5 over 6. On this first one, the x's cancel out, so I just have 6 times 1. On my second one, I can simplify. 6 divided by 3 is 2, so I have 2x. On my last one, the 6's cancel out, and I have 5x. I want to go ahead and subtract 2x on both sides. I get 6 equals 3x. I'm going to go ahead and divide both sides by 3, and I get x equals 2. On number 9, it wants me to write the quotient in standard form. What I do here is I want to multiply by the complex conjugate of the denominator. All that means is I change just the sign in the middle. If this number out front was negative, it would keep that sign. I only care about changing the middle sign. So I'm going to multiply both the top and bottom by 3 plus 3i. So on my top, I'm going to have 4 times 3, which gets me 12. 4 times 3i gets me 12i. 2i times 3 gets me 6i. 2i times 3i gets me 6i squared. On the bottom, I have 3 times 3 gets me 9. 3 times 3i gets me 9i. Negative 3i times 3 gets me negative 9i. Negative 3i times positive 3i is negative 9i squared. I'm going to go ahead and combine like terms. So I have 12, and then in the middle, I have 18i. And then I also have this 6i squared. Remember, I squared is the same thing as negative 1. Same thing on the bottom. I have this 9 out front. The 9's in the middle cancel out. So I have minus 9 times negative 1. I want to multiply those two parts by the negative 1's. So I have 12 plus 18i. Then it's going to turn into a negative 6 over 9 plus 9. I want to combine like terms again. 12 minus 6 is 6 plus 18i divided by 18. All three of these numbers are divisible by 6. So I want to divide them all by 6. This gets me 1 plus 3i plus 3 as my final answer. I can only divide these numbers if all of them are divisible by the same number. If only these two 18s were divisible, I couldn't do it. Number 10 wants me to simplify the expression. I am subtracting. Notice there is a minus sign in between. Lots of people on the test missed the minus sign and instead multiplied. What you just want to do is distribute that negative. So then it's going to become negative 4 minus 5i, and then you combine like terms. So 3 minus 4 is negative 1. Negative 6i minus 5i is negative 11i. That's my final answer. On number 11, there is no sign in between, so this is where I want to multiply. 5 times 3 gets me 15. 5 times negative 2i gets me negative 10i. 4i times 3 gets me 12i. 4i times negative 2i gets me negative 8i squared. I want to combine like terms in the middle. So I have 15, and then negative 10i plus 12i gets me 2i. Then I have negative 8 I squared is negative 1. Then I want to rewrite the last term. So negative 8 times negative 1 turns into positive 8. Then I can combine like terms. 15 plus 8 gets me 23 plus 2i. Remember, I always write the real number first, and then I write my imaginary number. Number 12 wants me to solve the quadratic equation by factoring. If I take a look, all three of these numbers are divisible by 3. So I'm going to start off by dividing out my 3. I get x squared plus 6x plus 9 equals 0. Then factoring is I look at the end number and look to what multiplies to the number in the middle. Adds to the number in the middle. So I'm looking for what multiplies to 3 and adds to 6. This is going to be 3 and 3. Then I want to take each of my factors and set equal to 0. Since they are the same, I only have to do this once. I want to subtract 3 on both sides, and I get x equals 3. Number 13 wants me to solve using square roots, so I'm going to add 4 to both sides. And I should ultimately take a square root to get my answer. So I have x plus 3 squared equals 4. I want to get rid of my exponent, so I take the square root of both sides. This gets me x plus 3. Whenever I personally draw on that square root symbol, I get two answers, plus and minus. And then the square root of 4 is 2. I'm going to have two equations from this point to solve. I'm going to have x plus 3 equals 2, and x plus 3 equals negative 2. On the test, the biggest problem I saw here was people forget that you get two answers, so they were only giving me one. The first one I want to subtract 3 on both sides. This gets me x equals negative 1. Same thing for the second one. This gets me x equals negative 5. Number 14 wants me to solve by completing the square. In order to complete the square, I want to get all of my variables on one side and all of my numbers on the other. So I'm going to move this 6x over to the other side. So I have 55 equals x squared minus 6x. I could move that 55 to the right side if I wanted, and then have the x squared minus 6x on the other side. I'm just going to leave it like that. To complete the square, I want to take half of my b value. So I want to do 1/2 of negative 6, which gives me negative 3. And I'm going to square that and add it to both sides. So actually, I'll switch them now. So I'm going to have x squared minus 6x. And then I am adding negative 3 squared to both sides. Negative 3 squared is really 9. Then I want to factor my left side. So what multiplies to 9 and adds to negative 6? This is negative 3 and negative 3. So because I get two of those, I can write it squared. And then 55 plus 9 gives me 64. This is looking kind of like what we just did in number 13 now. So I can go ahead and solve it using square roots. I'm going to square root both sides. This gets me x minus 3 equals plus or minus 8. Then I can split into two equations. I'll just do right here. I'm going to have x minus 3 equals 8. X minus 3 equals negative 8. For my first one, I add 3. I get x equals 11. My second one, when I go to add 3, this gives me negative 5. Number 15 wants me to solve using the quadratic formula. So in order to do this one, I need all of my terms on one side. I'm going to subtract 3x on both sides. Then I get 9x squared minus 3x minus 10 equals 0. My a value is 9. My b value is negative 3. And my c is negative 10. Then I want to plug into the quadratic formula, which remember is x equals negative b plus or minus the square root b squared minus 4 times a times c divided by 2a. So then I'm plugging into that. I get x equals negative 3 plus or minus the square root of negative 3 squared minus 4 times 9 times negative 10, all divided by 2 times 9. So then I want to go ahead and type this into my calculator. what I'm going to do is I'm going to go to Math, arrow over to Fraction, choose the first, oops, let me do that again because it was on the screen. Math, arrow over to Fraction, choose the first choice, and then I'm going to type in one of these things. So I'm going to do -3. Then I can only do plus or minus. I'm going to start with positive. Then I'm going to go second square root, -3 squared, minus 4 times 9 times -10 over 2 parentheses 9. I press enter. I'm going to round to 3 decimal places, so this gives me 1.234. And then I want to do the same thing for the negative. If I press second enter, it copies the equation for me. So I can arrow back over and then change that plus sign up top to a minus sign. And this one gives me -0.901. Let's move that decimal. I don't like where it goes. So those are my two answers here. If the calculator is giving you an error, it probably means you put a negative sign or a minus sign where a negative sign should have gone. Number 16 wants me to solve the polynomial equation. It is 4 terms, so I'm going to try to factor by grouping. I'm going to break it up into 2 pieces. I want to look for what the first group has in common here. They both have x squareds. So I'm going to pull out an x squared. That leaves me with 2x. And then my second term, anything divided by itself is always 1. In my second group, I always want it to be positive. So I'm going to pull out a negative. And both of these can be divided by 9. So I'm going to pull out -9s. I write that in between. I'm left with 2x minus 1, still equals 0. I want to go ahead and take the 2 outside pieces and put those together in a group. So I have x squared minus 9 times 2x minus 1 equals 0. Then I can go ahead and take each of my factors and set equal to 0. The first one I can add 9 to both sides. I get x squared equals 9. I can take the square root. This is going to give me plus and minus 3. On the second one, I add 1 to both sides. I get 2x equals 1. I want to go ahead and divide both sides by 2. This gets me x equals 1/2. Number 17 wants me to find all of the solutions to the equation algebraically. Because I have a radical, I need to start off by getting rid of that, and I'm going to square both sides. So 2x squared is going to give me 4x squared, because remember I distribute that exponent to both pieces. And then on my right side, I get rid of that radical, which is just going to give me x plus 3. Then I want to go ahead and subtract these over. I'm going to move this over to the other side. Minus x minus 3. So then I have 4x squared minus x minus 3 equals 0. I can solve any way I want. I'm going to use the AC method. My a is 4, my c is -3. So AC is -12, because I took 4 times, oops, I should have written that out. I have 4 times the -3, which gives me -12. So I'm looking for what multiplies to -12 and adds to -1. That is -4 and +3. So I'm going to split up my middle piece into those 2 numbers I just wrote. I have 4x squared, and I'm going to have minus 4x plus x minus 3 equals 0. And from here, I can factor by grouping. So I'm going to break these up into 2 groups. I'm looking for what each group has in common. This one has a 4x. And then 4x squared divided by 4x is x. -4x divided by 4x is -1. On the second group, I can divide by 1. This just gives me... That was supposed to be 3x. That's why. I'm like, where did I mess up? So I didn't divide by 1. I divided by 3. And this should have been a 1. If my inside pieces don't match, that means I've done something wrong. So that's how I was able to tell I made a mistake there. Then I can take my outside pieces and set those in one group. And my inside pieces go together in another group. I want to take those and set them equal to 0. So I have 4x plus 3 equals 0. 4x equals -3. Divide both sides by 4. I get x equals negative 3/4. That's one of my answers. And then I have x minus 1 equals 0. I add 1 to both sides. I get x equals 1. Okay, so in this one, I again want to start off by squaring both sides. I am going to, because I have two radicals, I'm going to have to do this twice. So I'm going to start off by squaring my first side. When I get to the right side and I square, remember this is the same thing as multiplying by 2 minus the square root of x twice. So on the left side, the radical just goes away. On the right, I want to distribute. 2 times 2 is 4. 2 times negative square root of x is negative 2 square root of x. Negative square root of x times 2 is negative 2 square root of x. Square root of x. Negative square root of x times negative square root of x is positive. And then my radical goes away, x. Then I want to combine like terms. So I have x plus 1 equals 4 minus 4 radical x, because I can add those two negative 2's out front together, plus x. Then I want to subtract x on both sides and subtract this 4 out front on both sides. Leaves me with negative 3 on the left equals negative 4 square root of x. I can go ahead and square, actually let's divide. I'm going to divide by negative 4 on both sides. This gets me 3/4 equals square root of x. Then I can go ahead and square both sides, which gives me x equals 9/16, because I can distribute that squared to each of the top and bottom separately. Number 19 wants me to find all of the solutions to the equation algebraically. So what I want to do is I first want to isolate the part with the exponent. I'm going to start off by subtracting 10 on both sides. This gets me negative 64. Then I want to go ahead and divide both sides by negative 1, which gets me 64. Then I want to go ahead and raise my both sides of my equation to the opposite exponent. So both sides are going to be raised to the 2/3 power. This is an exponent, and I am not multiplying something here. That was another common mistake on the test, is people were multiplying here when they should have been raising to an exponent. So what I want to do is I want to go to type in 64 to the 2/3 power, which gets me 16. And then I have x minus 10. I want to add 10 to both sides. I get x equals 26. Number 20 wants me to solve algebraically. So what I want to do here is I want to get all of my variables to one side and all of my numbers to the other. I'm going to start by moving this negative 65 over, because I like working with positive x variables. That is going to give me 19 is less than 63x plus 41. Then I want to subtract 41 on both sides. 19 minus 41 is not something I'm confident to do in my head. Negative 22. Oops. And I want to leave this with a inequality. I don't ever want to change this to an equal sign, because I noticed when a lot of people changed it to an equal sign, they got messed up and they forgot which sign it was. Then what I want to do is I want to go ahead and divide both sides by 63. I'm pretty sure this doesn't simplify, but I'm going to type it into my calculator just to double check. It does not. So I'm going to rewrite this. X is going to be first, and then when I write the x first, I flip the inequality symbol, and then I have negative 22/63. Number 21 wants me to solve it graphically, so what I want to do here is get everything equal to 0, or on one side and have 0 on the other. Then I want to go ahead and graph this, so I'm going to have y equals, let's clear this up, x squared minus x minus 6, and then I'm going to graph this. And it looks something like this. I want to figure out my 0, so I'm going to go second calc, 0, and then I'm going to go to the left of my 0, press enter, arrow over to the right, press enter twice. This one is negative 2, And I'm going to do the same thing for the other one. So then right here I'm going to press enter, cross the x-axis, press enter twice. And this one is 3. I want this to be less than or equal to 0. So all of my numbers that are less than or equal to 0 are between -2 and 3 because they're connected with a line. So I'm going to do -2 and 3, and then because it has the underline with it, these get the square brackets. If I'd been going the other way, I would have had infinities, and remember, infinities always get parentheses. Number 22 wants me to identify the vertex of this equation by converting to vertex form. So the first thing I want to do, this one is completing the square. I'm going to pull out a 5 from both of my first two terms. So 20 divided by 5 is 4. And then I'm going to leave that 27 alone for right now. So then I want to take half of this value inside the parentheses for the b value, and that is going to give me 2. So I'm going to go ahead and add 2 squared inside the parentheses. And then I still have that 27 on the outside. Then, because I am working on one side of the equation, I need to cancel out that 2 squared I just added, but it's already being multiplied by this 5. So the opposite of positive 5 is -5, and then I also want to multiply by the 2 squared that was on the inside. Then I just want to simplify from here. So I'm going to have y equals 5, and then x squared plus 4x plus 4, and then plus 27, -5 times 2 squared. Gets me -20. I want to factor the inside of the parentheses and then simplify the outside. So I'm looking for what multiplies to 4 and adds to 4. It will always be that number I had in parentheses that I squared earlier. So x plus 2, and then this whole thing is squared because 2 times 2 gives me 4, 2 plus 2 gives me 4. And then on the outside, I want to go ahead and subtract 20 from 27, which gets us 7. Then to give my vertex, I am going to, remember, opposite the sign in parentheses, and same as the one outside. So -2, 7 is my vertex. Number 23 wants me to give the x-intercepts of the graphs. Remember, x-intercepts are the same thing as zeros. So I want to go ahead and graph this one. And then once it graphs, I want to figure out where these are crossing the x-axis. So same thing like I did on the problem above. I'm going to choose a point on the left side, cross the x-axis, choose a point on the right side. My first one is -2. Then I'm going to go do the same thing over on the other side of the graph. I press enter, arrow more to the right, press enter again. This one is 7. So those two numbers are my answer here. Number 24 wants me to use long division to solve. So what I'm going to do is I am going to write this part goes inside, and then anything I'm missing gets 0x placeholders. And then the outside, I don't have to do placeholders. I can if I want, but I don't have to. I'm looking for what I need to multiply x cubed by to turn it into x to the 6, which is another x cubed. So when I multiply those together, I get x to the 6 plus 3x cubed. I want to put this, I want to put the x cubed above the matching term below, under the division symbol. And then I want to line up those pieces I just wrote out. So I'm going to have x to the 6 and 3x cubed. I want to subtract those out, so I'm going to change those signs. The x to the 6 cancels out. The x to the 5th doesn't need to be there because it's a 0. But I should bring down my 2x to the 4th, my -3x cubed, and then everything that follows it. Then over here, I want to figure out what I need to multiply x cubed by to turn it into 2x to the 4th. That is 2x. This gets me 2x to the 4th plus 6x. So I want to write the 2x up above the matching piece. So right here. I'm going to write my terms down here under their corresponding pieces. I'm going to change their signs. Those x to the 4th cancel out. I'm going to bring down the negative 3x cubed. I'm going to bring down the 0x squared. The 6x's cancel out and turn into 0x. And then the negative 9 goes down. I'm looking for what I want to multiply x cubed by to turn it into negative 3x cubed. This is negative 3. That is going to give me negative 3x cubed minus 9. So then I want to change those signs. Oh, and I also want to write this up here, what I just wrote. They cancel out. Everything else cancels out, or was already a 0. So I have no remainder. This part up top is my answer. So I have x cubed plus 2x minus 3. If I had a remainder, the part I wrote at the end, right here, would be written as a fraction divided by my divisor. Number 25 wants me to write the domain. This is where I take the denominator and set it equal to 0. I want to solve this. Typically, you'll factor on this one. I can solve by square roots or factoring. I'll solve by factoring. So I'm looking for what multiplies to negative 9 and adds to 0 because I don't have a middle term. So that's positive 3 and negative 3. I want to take each of those factors and set equal to 0. I get x equals 3 and x equals negative 3. These are not my final answers. I want to write it in interval notation. So I'm going to have negative infinity to my smallest value, which is negative 3, unioned with in between those two values from smallest to largest, so negative 3 to 3, unioned to 3 to infinity. Oops, that's kind of off the screen. There we go. This next one wants me to list every possible rational 0 for this. I'm not looking for the actual zeros here. I'm just looking for the possible rational zeros. This is the PQ test. So P is my end value. Q is my first value. I'm going to start off by finding my factors of my end value. All of these should have plus and minus up front. So I'm going to have plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, 6, 12. Then Q is my leading coefficient. I want all of those factors, which are just 1 and 5. Then for my every possible rational factor, I'm going to take P and divide by Q. So all of these values I just wrote, I want to divide by 1. So all of those are going to stay the same when I divide by 1. And then I'm going to do the same thing and divide all of these by 5. And all of these are my possible rational zeros. I'm not looking for the actual answer here, just the possible answers. Number 27 wants me to factor two linear factors given that 2i is a 0. i's come in pairs, so I'm always going to have a positive 2i and a negative 2i. I want to start off by multiplying those together. That's going to give me x squared plus 2ix minus 2ix minus 4i squared. If I simplify this, it's going to give me x squared. My middle terms cancel out. Negative 4 times negative 1. So it's going to give me x squared plus 4. Then I want to take this value and do long division with this polynomial. So again, I'm looking for what I need to multiply x squared by to turn it into x to the 4th. I'm going to do my scratch word down here, which is x squared It's going to give me x to the fourth plus 4x squared. So then I want to match, or want to write that up above, and then I want to match those down below. X to the fourth, 4x squared. Subtract those out. My leading term goes away. Now I have negative 7x cubed plus 12x squared. And I bring down those other ones. Minus 28x plus 48. Then what I want to do is I want to look for what I need to multiply by to turn it into a negative 7x cubed, which is just negative 7x. Then this gives me negative 7x cubed minus 28x. So I'm going to go match those up. And I also want to write this negative 7x up above. I'm going to change my signs here. 7x cubes cancel out, so then I have 12x squared plus 0x plus 48. So I'm looking for what I need to multiply to turn it into 12x squared. That is positive 12. I multiply, that gets me 12x squared plus 48. Oops. Yeah, that's fine. Then I want to change those signs. And they all cancel out nicely, which is perfect because when I'm factoring the linear factors, it should. Now what I need to do is I need to factor this. So I'm looking for what multiplies to positive 12 and adds to negative 7. It is going to be negative 3, negative 4. And I want to also write the two factors that I had at the beginning. So x minus 2i and x plus 2i. This is my final answer for number 27. Number 28 wants me to find all of my asymptotes. To get my vertical, I want to take the denominator and set that equal to 0. I can either factor or, in this case, I can solve by square roots. So I'm going to solve by square roots. I get x squared equals 4. I want to take square root of both sides. Gets me positive and negative 2. For my horizontal, I want to take a look at my leading terms and their coefficients, or exponents. They're both the same, so in this specific instance, I'm going to divide. That's going to give me y equals 5. But if my top was longer, I would actually have to do long division and I'd get a slant asymptote. If my denominator is bigger, I just automatically get y equals 0. Number 29, I need to graph this. My first step is to factor if I can. I cannot, so I'm going to start on step 2. This is to plug in all of my x's as zeros. So when I do this, I get negative 2. That is my y-intercept. Then my next step is to take my numerator and set equal to 0. And I want to square root both of these on the final. If you do have to graph, it will be nicer numbers. Oh, that's not it. .82. So like here and here. Then I want to take my denominator and set equal to 0. This is going to give me my vertical asymptote. And let me go grab a spreadsheet of paper. My next step is to find my horizontal or my slants. This one is going to have a slant because the exponent is larger. So I need to do division here. I can either do long division or synthetic division. I am going to use synthetic. So I'm going to take the coefficients and write those down for my numerator. And then my answer to 4 is always my number on the outside. So then I can drop down. Negative 3 times 1 is negative 3. Oops. If I rewrite this as the equation of a line, it's going to be y equals negative 3x minus 3. And then this number at the end does not matter. So I want to go ahead and plot this line. So I'm going to go down 3. And then my my slope is negative 3. So I'm going to go 3 down from there. 2, 3. And then right 1. And I want to connect those 2 points. This is an asymptote, so it gets a dashed line. Then I have points here that I can connect, and I need an additional point on the right side of this asymptote to see if it's above or below that slant. So I am going to pick 2 to plug in. So when I type this into my calculator, I want to make sure my numerator is in parentheses when I type it in. Which gets me negative 10. So I plugged in the point 2, I got out the point negative 10. I'm going to go ahead and plot this on my graph. 2, negative 10 is right here, so this is below those lines. Okay, so this next one wants me to evaluate for x equals 3.2. I am just going to plug in 3.2 into this equation, and then type it into my calculator. If I am on an older calculator, I cannot type it like I just did. I would want to make sure my entire exponent is in parentheses before typing this in. So this gets me 601.845. Number 31 says, how much money will you have in a bank account if you invest $3,500 for 5 years in an account that earns 3.4% compounded quarterly? So that's 4 times a year. The formula I am using here is A equals P times 1 plus R over N to the NT power. So I want to plug in there. And then I would just want to go ahead and type this into my calculator. Oops. This is money. Money always goes to 2 decimal places. And because of that 7, I'm going to round to 59 cents. Number 32 wants me to evaluate. So I'm going to plug in. On a newer calculator, I can go to Math, down to log base, and then type this in exactly as it looks like on my paper. It's going to give me 1.953. If I have an older calculator, I can go log 15, so the argument, and then divide by log the base, cheers 4, and it should give me the same answer. Same thing for number 33. I just want to go ahead and type this into my calculator. I'm going to use the log base for this one, which gets me 2.128, and that's as far as I need to go on this one. This next one wants me to expand the logarithm, so I'm going to have log base 4. Anything on the top gets separated with plus, anything on the bottom gets separated with minus, so I'm going to have log base 4 of 3 plus log base 4 of x squared minus, because it's on the bottom, log base 4 of 2 minus log base 4 of y. Again, both of those were on the bottom, so they both got minuses. Then I just need to take a look and make sure I don't still have exponents. I do, so I need to pull that out front. I have log base 4 of 3 plus 2, log base 4 of x minus log base 4 of 2 minus log base 4 of y. And that is my final answer. Number 35, I'm going the other way, so I want to start off by putting my exponents back where they belong. So then this is going to give me ln of 5 plus ln x squared minus ln y cubed minus ln z to the 1/2. I can rewrite z to the 1/2 as the square root of x, so I'm going to do that. Oh, that looks terrible. Then I just want to go ahead and put them all together. I have two things that have plus in between. Those go on the top of the fraction. Two things with minus, those go on the bottom. So this is my final answer here. Number 36 wants me to solve, so what I want to do here is I am going to divide both sides by 2 to start off with. 2. I want to get my base alone. So then this gives me e to the 4x equals 36. Because it's base e, I can rewrite as a logarithm. The answer and the exponent switch places. This is ln of 36 equals 4x. I can divide both sides by 4. Ln of 36 is not the same thing as 36, so I need to type this into my calculator exactly as it appears. Ln 36, close off those parentheses, divide by 4. This is going to give me 0.896. Okay. Number 37, I want to solve. I wish I hadn't boxed over this. I'm going to start over by subtracting 4 on both sides. It's going to give me 15. I want to divide both sides by 3. This gives me 2 to the x equals 5. I can rewrite this as a logarithm. It's going to be log base 2 of 5 equals x, because the exponent and answer switch places. So then I can go math, log base 2 of 5. This one gives me 2.322. Okay, number 38. Both of these have a log base on both sides, or both sides have a log base, and then there's nothing else. So I can just take my insides and set those equal to each other. I'm going to have 3x minus 7 equals 6x minus 19. I want to start off by subtracting 3x on both sides. I get negative 7 equals 3x minus 19. I want to go ahead and add 19 to both sides. Gets me 12 equals 3x. I can divide both sides by 3. And I end up with x equals 4. Number 39, I have 2 logarithms on one side and a number on the other. I want to start off by condensing. Remember, adding is turning into multiplication. Subtracting is turning into division. So I'm going to condense. I'm going to have ln of 3 times x minus 8 equals 5. I want to go ahead and distribute that out. This turns into 3x minus 24. I can rewrite it as an exponent. It's going to become e to the 5th equals 3x minus 24. I want to start off by adding 24 to both sides. I get e to the 5th plus 24 equals 3x. Divide both sides by 3. I'm going to type this into the calculator like I have it written out so I don't lose something when rounding. When I type this in, I want to make sure my numerator is in parentheses. So I have e to the 5th plus 24, and then divided by 3. This gives me my final answer of 57.471.